Hello guys, welcome to my YouTube channel. So today we're going to learn about the cylindrical coordinate system. You can look at my previous video on the polar coordinate system because it's going to help you with understanding this one. So the cylindrical coordinate system. So the cylindrical coordinate system. Okay. In French we say the système de coordonnées cylindriques. So it's a cylindrical coordinate system. It uses from the Cartesian coordinate that you know, okay, from the Cartesian coordinate, you're going to use the angle phi. You're also going, then you're also going to use this radius rho. Then you're going to use e rho. We found e rho. You can look at my previous video on how we found e rho. So we found e rho to be cos phi in the direction of e plus sine phi in the direction of g. Okay. So now in the cylindrical coordinate system, we are locating a point in 3D. So let's say that point is here, and we call that our point as point M. Then let me call this point N. So with the cylindrical coordinate system, here is what you're going to do. You're going to move from O to N. Then from N, you're going to go upwards to the point M. Let's say your point M is here. Okay. So from here, this should be a straight line. It's just my drawing. This is parallel to the z-axis, so therefore the direction of nm, the direction of nm is k as well. Okay, k is the unit vector in the direction of z. Okay, then we also know that the e is a unit vector in the direction of x. Then g is a unit vector in the direction of y. So for the unit vectors in the direction of x and y and z, depending on the book, you'll be using different ones, but here I'll be using e, g, and k. Okay, so the other thing that you need to know here is identifying your OM in the Cartesian cylindrical coordinate system. So identifying your point M from here is very simple. So your OM will be equal to, what is your OM going to be equal to? You move ON, so it's going to be ON plus NM. Okay, so now what is your ON? ON is going to be rho, E rho, okay, plus what is your NM going to be? NM is going to be Z in the direction of K. Okay, so for people who are finding difficulties, so ON, the magnitude of ON is rho. Then which direction we've defined E rho. Then going upwards is just the same as going in the Z direction. So we will say Z in the direction of K. Okay, so the cylindrical coordinate system borrows from the Cartesian coordinate system, borrows the Z and K direction. So whenever you go up, it's just Z in the direction of K. So this is how you find the OM. So with cylindrical coordinates, the spherical coordinate system, then here we also defined in the polar coordinate from a previous video, we defined the phi. Okay, so you're going to have a system of vectors. This system of vectors is going to be e rho, phi, then and k. Okay, so this is none other than an extension of the polar coordinates in 3D. Okay, so this is what you need to know about the système de coordonnées cylindrique. So if you want to convert, so there are no new unit vectors that are defined in the système de coordonnées cylindrique, because you borrow from the, you borrow e rho, you also borrow k from the polar coordinate systems. Okay, then we found our e rho. So the other important thing is finding e rho and phi. Okay, so e rho we found it to be cos phi in the direction of e plus sine phi in the direction of g. Okay, then phi we also found phi to be negative sine phi in the direction of e plus cos phi in the direction of g. Then we said that you find, when you find the derivative of e rho with respect to phi, you're going to find phi. Okay, We're going to find if. So we found if from this property. Okay. So the unit vectors associated with the system the coordinate cylindric are the same ones, E row, if the same ones from the polar coordinate system, then um, EZ or K. Okay, so these are the coordinate systems that these are the bus vectors that are associated with the system de coordonnées cylindrique. Okay, yeah. So this is everything that you need to know about the system de coordonnées cylindrique. The first thing that you need to know is identifying identifying the point M. Okay, then this is rho, then this is phi, the angle phi, then this is euro, then going upwards is just the same as this is parallel to the z direction. So you say z in the direction of k, then here you say rho in the direction of rho to identify your OM. Okay, then as usual, if you want to convert OM into the bars Cartesian, you just write an expression of euro, you replace here with an expression of euro, and it will give you OM in the bars Cartesian. So this is everything that you need to know about the system de coordonnées cylindrique. Thank you for watching.